Have you ever wondered how honeybees build those incredible, perfectly symmetrical honeycombs? It's one of nature's most stunning architectural feats. For thousands of years, humans have marveled at the bees' ability to create flawless hexagonal cells. And for a long time, we didn't even know how they did it. Do they have some kind of built-in ruler? Do they measure angles? The truth is even more amazing. Let's start with the shape itself, the hexagon. Why not squares or triangles? Well, mathematicians figured out that hexagons are the most efficient shape for tiling a surface. They use the least amount of material in this case, beeswax, to hold the most amount of honey. Think about it. If they used circles, there would be gaps between them, wasting precious space. Squares would work, but hexagons have shorter perimeters for the same area, meaning less wax is needed for each cell. This is pure geometric genius, and bees figured it out millions of years ago. It's a principle called the honeycomb conjecture, and it took humans centuries of complex math to prove what bees knew all along. So, how do they build these perfect shapes without any tools? For a long time, scientists thought bees were individually measuring and constructing each hexagon. But recent studies have revealed something far more fascinating. It turns out, the bees don't actually build hexagons at all. They start by building circular cells. That's right, simple circles, packed closely together. Here's where the magic happens. The bees generate heat with their bodies, warming the beeswax to about 45 degrees Celsius, or 113 degrees Fahrenheit. At this specific temperature, the wax becomes soft and pliable. The surface tension of the softened wax, combined with the pressure from the surrounding circular cells, naturally pulls the walls into straight lines. Where three cell walls meet, they automatically form angles of 120 degrees, the exact angle needed to create a perfect hexagon. So, it's not the bees being tiny architects, but rather a brilliant collaboration of biology, physics, and chemistry. They simply create the right conditions, and the laws of nature do the rest, transforming simple circles into a strong, efficient, and beautiful hexagonal structure. It's a self-organizing masterpiece. But the bees' genius doesn't stop at their homes. Their communication is just as mind-blowing. Imagine you find a fantastic new restaurant and want to tell your friends exactly where it is. You'd probably send them a pin on a map, right? Well, bees have their own version of GPS, and it's a dance. It's called the waggle dance. When a forager bee finds a rich source of nectar, it returns to the hive and performs this special dance on the vertical surface of the honeycomb. The dance is a figure-8 pattern. The direction and duration of the central waggle run convey incredibly precise information. The angle of the waggle, relative to the vertical line of the comb, tells the other bees the direction of the food source in relation to the sun. So, if the bee waggles straight up, it means fly directly towards the sun. If it waggles 30 degrees to the right, it means fly 30 degrees to the right of the sun. It's an abstract language of angles. And what about distance? The longer the waggle, the farther away the food is. A 1-second waggle might mean the flowers are a kilometer away. The other bees gather around, feeling the vibrations of the dance and even smelling the scent of the flowers on the dancer's body. They decode this information and then fly out, often navigating miles with remarkable accuracy to find the exact spot. This symbolic language allows thousands of bees in a colony to coordinate their efforts, acting like a single, super-efficient organism. Now, let's talk about their ability to fly. It seems simple, right? But for a long time, based on our understanding of aerodynamics, scientists couldn't figure out how bees could even get off the ground. According to classical physics, their wings were too small, and did unflap fast enough to generate the lift needed to support their relatively chunky bodies. It was a famous paradox. Of course, bees fly, so our science had to be missing something. High-speed cameras and advanced fluid dynamics modeling finally solved the puzzle. It's not just a simple up and down flapping motion. A bee's wings beat incredibly fast, over 200 times per second. More importantly, they use a complex rotational motion. On the downstroke, the wing sweeps forward and down. Then, it rapidly rotates and flips over for the upstroke, sweeping backward and up. This rapid rotation creates tiny, swirling vortices of air on the leading edge of their wings, like miniature hurricanes. These vortices create a low-pressure zone above the wing, which generates a huge amount of extra lift. So, it's not just flapping, it's a sophisticated combination of flapping, rotation, and creating air whirlpools that allows them to defy what we once thought were the laws of flight. They are masters of the air, able to hover, fly backward, and carry heavy loads of nectar and pollen back to the hive. And that brings us to their most critical role in our world. Bees are not just making honey, they are making our food possible. About 1/3 of the food we eat depends on pollinators like bees. Fruits, vegetables, nuts, and even the crops we feed to livestock all rely on these tiny workers to transfer pollen from one flower to another, allowing the plants to produce fruit and seeds. Think about your favorite foods: apples, almonds, blueberries, avocados, cucumbers, pumpkins. The list goes on and on. Without bees, supermarket shelves would look drastically different. The variety and abundance of our food supply would plummet. They are the unsung heroes of our agricultural system, performing a service that is practically priceless. Each time you see a bee buzzing around a flower, remember that it's not just collecting food for itself. It's helping to put food on your table. From their perfectly engineered homes and symbolic dance language to their seemingly impossible flight and their vital role in our ecosystem. Honeybees are truly some of the most amazing creatures on the planet. They show us how powerful collaboration, efficiency, and a little bit of physics can be. So, the next time you enjoy a spoonful of honey or a delicious piece of fruit, take a moment to thank a bee. Thanks for watching. If you found this as fascinating as I do, be sure to hit that like button and subscribe for more deep dives into the wonders of nature. See you next time.